Hi, welcome to ELF Center 1. Our year-long theme is Earth and Sky, and this one is Air and Sound. So as always, we have our little outline taped here on the lid so you can refer to it, and you can also refer to the outline on mitchellpta.org under ELF, Programs and Events, then ELF. So I just want to kind of show you this center looks like it has a lot, and it really does, but they're really short experiments. We have 4 of them, so I'm going to brush through them really quick. If you've got any questions, you can email me at mitchellelf@gmail.com. So we're going to start with the first activity, which is called Air Pocket, and this shows that air has volume and it occupies space. So we use this bin, which will be separate and won't fit in here, so you're going to have to look for that. And we have some plastic glasses. Let's see, tall and short. Hang on, stay, just look right there. I'm going to grab another one. Rumble, rumble, rumble. There it is. Okay. I'm back. Okay, so we have a tall and a short glass. So what you're going to do with this center, or this experiment, is pour some water into this here tub. Is this the right one? Yeah, it is. Okay. We'll have the picture in there too, but I don't know if you need it because you have plenty of space in there. So we're going to show that the air has volume and takes up space with these 2 cups. So we're going to put them into the tub and see what happens to the water level in the glass as we push them down. So it's basically a very simple experiment. So does the water rise into the glass? Why not? It does here. It's just around the outside of the glass because the air is taking up space. So this is a good demonstration for them to see that, you know, of course water will go in if we tip it up, but otherwise it looks like there's a line, but that's the surface line of the water. There's no water in the cup. And to further demonstrate it, we could put air in a Ziploc bag. And so we have a whole box of Ziploc bags in here. So they can fill up one, fill it with air, and then they can try to get the air out without popping it, and they can actually feel that air takes up space. So, because the air is kind of a hard concept to understand and grasp, that we're all breathing it and experiencing it, but it's not touchable, it's not really tastable or smellable. So that gives one example of that it has volume. So that's really fast. Again, if you have questions, you can email me or call me. Part 2. Did I need the code? No, okay. Part 2 is bottled air. So it shows that air, again, takes up space, and even though it's invisible. So we have a bottle in here, and we're going to take a balloon. And you can decide as a parent how many kids you want to let try this and get their germs all over. We'll have plenty of balloons in there. But you take a balloon and you stretch it over the mouth. And you can ask some questions about it, like, you know, what's happening? Will this balloon blow up? And you can demonstrate outside in the regular air that a balloon will blow up. We're limited, so I'm not going to blow it up. But I will show you this one, because that's going to be fun. I'm going to turn really red. No, I can't blow it up. So that is showing us that the air is taking up space, and the bottle is already completely full of air, except for my limited little blow up. So that shows the air is invisible. I'm going to take that and that. Okay, so the next one is called Killer Straw, and it shows the push of forced air. So we have a potato, which we have, but you need to bring in your own, and we have these dangerous straws. So what you're going to do is 2 demonstrations, and you can use a Sharpie to mark how deep the straw goes. And you stick it in the potato, it goes pretty far. So I'm going to take my Sharpie and mark how far it went. Oops. Not a very good line. And then I'm going to cap it and see what happens. Okay, there's the Sharpie mark. Good couple inches. And then I'm going to put my finger over the hole and try it again. Oh, that went just as far. I love science. Okay, so maybe our crooked straws don't work. I don't know for sure, but what should be happening is the open-ended straw bends and only a little bit of the straw goes into the potato. So we're going to put in some plastic straws and see how that goes. We might file another video, but I'm not sure. You'll figure it out. You can skip it. You can talk. We are through it. They're only kindergartners through 4th grade. Okay. Anyways, if it works accordingly, you should have two lines on your straw, and one with open end or one with capped end will be longer. So you'll have to determine what that is. Love it. Love it. Then throw away your potato. We don't want eyeball potatoes growing in there. All right, the last one, we're going to take some water from the bin and put it in this little tub. And we're going to put a little food coloring in there so that the kids can see if the water rises a little bit easier. So I got some water in there, got some food color in here. Oh, I think I put in too much. I did put in too much. Okay, so we also have a candle. Sorry about that. A little tea light, so we actually don't need nearly that much water because we want the candle to sink in the water. There we go. A little food color. Let's do red for Christmas. Isn't that lovely? Oh, I feel like Julia Childs. Okay. Then we're going to light the candle if I remember right, because I'm trying not to read my notes while we're talking here. Stirring up that food coloring. Okay. So oxygen is necessary, air, for the candle to burn. So this whole experiment, part D here, rising water, shows how air converts to energy and contracts when cooled. So it also introduces the ingredients or the component gases of air. So we're talking about oxygen, that this candle needs oxygen to burn. Of course, you need to be wary of what you do with the candles and the matches because we get some excited kids. All right. So we've got our candle lit, so we're going to talk about oxygen and how it makes up our atmosphere, and then we're going to take this jar, not a plastic cup because we don't want it to melt, and we're going to see what happens when we put it over the candle. Many adults probably know. All right, so the candle is, well, it's a big jar, which is good because you can talk all the time through it. Eventually the candle will go out and it will create a vacuum and pull up water into the jar so that something has been replaced. So you can talk to the kids about that. Again, it's detailed extensively in your outline. Here it's going, it's finally extinguished. Okay, so it's really hard to see, but that's why we food color the water so that the kids can see that it actually changed levels. Again, this is one you might have to talk through because the level is really hard to see. We might change jars, but if you get down eye level with it, you can see that it went up just a smidge. So that's that experiment. Again, if you have any questions or we're running low on supplies, let me know at mitchellelf@gmail.com. Thank you.